The good news is that feature extraction in Edge Impulse is quite simple. We don't have to calculate the fast Fourier transform or power spectral density by hand. To start, head to the data acquisition page in your project. You should see all of the samples that we collected in a previous lecture. Feel free to click on one to examine the raw data. I'll load one of the left to right samples, and you should notice that the plot looks just like the one we were examining in the previous lecture. The z-axis stays at around 10 meters per second squared thanks to the effects of gravity. Y hovers at around 0, and x oscillates back and forth, which we would expect from swinging our phone side to side. Load another example, say from the circle class, and see if you can spot differences between the classes. To generate features, we first need to create an impulse, which is Edge Impulse's term for a machine learning pipeline. Click on Impulse Design. On this page, you should see the first block representing your raw data. Let's leave the window size and step increase at their defaults. The processing block refers to our feature extraction method, so click on it to bring up some options. Edge Impulse will recommend the spectral analysis block for our motion data, which is what we want. Click to add that to our impulse. In the learning slot, add a neural network Keras block. We'll talk about neural networks in more detail in the next module, but know that a simple neural network works pretty well as a classifier for our motion data. Click Save Impulse and then navigate to the Spectral Features page. Here, you can adjust the settings for the different feature calculations. For now, we want to leave them at their defaults. Click Save Parameters. Select one of the left to right samples and take a look at the plots. These should look familiar from the last lecture. Note that Edge Impulse is also filtering out some of the high-frequency noise in each sample, which is why the first plot looks smoother than the raw data. The frequency domain and spectral power plots show us that we have a lot of power around 1 Hz in the x-axis. If you switch to an up-down sample, you can see how there's similar energy around 1 Hz, but it's for the y-axis. What do you expect to see when we load a sample from the circle set? If you guessed energy in the x and z axes around 1 Hz, you'd be correct. To create that circular motion, we move the phone left, right, up, and down. Because there's no front and back motion, there's no energy in the y-axis. Now, what do you expect for the idle class? We should see no energy because the phone should not have been moving at all. Click on the Generate Features tab and click the Generate Features button. Wait for a minute or two while Edge Impulse converts all of your raw samples into sets of features. When it's done, you should see some plots show up in the Feature Explorer. Feel free to move these plots around. As we mentioned in the previous lecture, the root mean squared value of each sample would actually work very well, as there is obvious separation among the class clusters. Try changing some of the other features to see if you see similar separation. Which features do you think would work best for this classifier? Unfortunately, we can't pick and choose features at this time, so we have to go with all 33 features for each sample. That should be few enough features to run on our phone or microcontroller board. Speaking of the microcontroller, if you collected samples for the Arduino as well, switch over to that project and let's repeat the process. Add your spectral analysis feature extraction block and your neural network block as your model. Don't forget to click Save Impulse and head to the Spectral Features tab. As we did with the phone data, click on Generate Features and click the Generate Features button. When that's done, you should have features just like from the phone project. These are stored as arrays on the Edge Impulse servers, so you don't need to generate features again, unless you delete the processing block from your Impulse design. These features are now ready to be used to train our machine learning model.